Before we start off with anything, I just want you to take a look at this.
Internet is that massive computer network, the one that's becoming really big now.
What do you mean? That's big? How does one not? What do you write to it like mail?
No, a lot of people use it and communicate. I guess they can communicate with NBC writers and producers. Allison, can you explain what internet is?
So as you saw that nearly 2 decades ago, we did not even know what internet was, and today we cannot imagine our lives without it. Same is the case with machine learning. In a decade or two, it will become such a powerful tool that it will become essential for everyone to have in the IT sector. And today in this video, we'll be covering everything of the first section of machine learning, which is data pre-processing. Let's get started. So this is what the code actually looks like that we are going to be writing in the entire video. Don't worry, I am going to be explaining every line step by step. So just to give you a basic idea on what we are dealing with, so here we import the libraries. We also import some new libraries that we need along the way. Then we import this data set right here. So I'm going to be explaining what this data set does, what we have to do in this, and what pre-processing actually is. So as you can see, we are just printing stuff. So you need to have a good grasp of Python to know this. And if you want a tutorial in R, just leave it down in the comments below and I'll make a tutorial for the R language if you're more comfortable with that. So here, as you can see, we are taking care of missing data. I'm going to deal with what this is. So just to give you a brief idea, this is this data right here that we don't have in our data set. Then we are encoding the data and we are encoding dependent variables. Then we are splitting it into a training set and the test set. Then we are doing feature scaling. So let me explain what actually all that is. So right here, as you can see, we have got a data set for a car company. Now, there are some variables here, which are the country on which the person who has bought the car is, then the age of the person, the salary, and if he has purchased the car or not. Now, just to give you a basic idea, the last column is dependent on all these 3 columns, right? So, if the person has purchased the car or not depends upon his country, age, and salary, right? And it's really easy to, scale this to a bigger thing so that we can just input the values and the model will tell us if we'll buy the car or not. But in this video, we are taking care of pre-processing, right? So we are just going to make this data more feasible for the computer to understand. So let's start with the missing data. Here, as you can see, we have got a few missing boxes. So this is very common once you're handling data sets. So you will have large chunks of data which have a few values missing. So you can actually predict with your machine learning model on what all will come here. So you can use 2 methods, which is mean and median. So what mean means is that you take the mean of all these values, is that you take the average of all these values and you put it in these columns. And for purchase, you have to turn this data into numbers and then you do the same thing. Then we are going to be encoding data, right? So as you can see, the machine learning model cannot understand strings, so it won't be able to understand Spain, Germany, France, and if it is a different thing or not. And if we just evaluate 1, 2, 3, 4 randomly, and that will indicate a pattern which will confuse the model afterwards. So what we are going to be doing, we are going to be encoding this so that the model can actually know what this is and how much frequently it is occurring. Same with this column, we are going to be encoding the yes and the no in binary as 1 and 0. Then we are going to be splitting the data into the training data and the test data. So basically, once we get a data set, we fraction some part of the data. Mostly it is 80% and 20% as the training data and test data respectively. Now here, as you can see, we have got a larger chunk of data for the training and just 2 columns for test. What this means is that we'll use all these columns to train the model or to train the machine to know to tell the machine what is actually happening here, and then we'll test our predictions with these 2 right here. This is part of data pre-processing, but more of this use comes when we use the regression models and once we make graphs and predict data and actually go inside machine learning. So we are going to be covering all of this and much more. So just stay tuned till the end of the video as I break down the entire code. So this is Google Colab and I highly recommend it if you are learning machine learning because it has all the libraries pre-installed and it gives a very handy visual look once you're dealing with machine learning models. So I'm going to be giving this a notebook to you in the description below along with this data set, and I highly recommend you to do it in Google Colab, but if you are not, I'll just link this notebook down in the description with the Python code so you can perform it on any IDE you want. So right here, once you get the data, it will be logged and you won't be able to edit it. So what I recommend you do is that you go up here to file, then you just go on save a copy in Drive right here, and it is creating a copy. And once it's done, it will create a new Colab notebook for you, which is ready to be filled with. So I'm going to delete all the code here. Okay, so we are all set and we have created a copy of the notebook. Now let's start by importing the basic libraries that we need for machine learning. So the first library we need is pandas. So let's import pandas as PD. So this is just the nomenclature that is followed in the machine learning community. So we use pandas as PD. Then we have to import a library named numpy, and we import this as np. Next, we are going to be importing the dataset. Now, if you have not uploaded the dataset here, just go on files. Then you will find a little upload guy here. Just make sure you are connected before you do this. So just the connect option will be coming here. So just connect it. This tick will come. Then you can upload any file. So I'm going to click on upload, and then I'm going to go on data.csv and enter, right? So data.csv is basically short for comma separated values. So this is the basic structure for all Excel sheets, Google spreadsheets, and everything like that. So we are also going to be dealing with that as well. So we have got the same data set as I showed you in the presentation. Here some values are missing, and it is not it is all not an encoded value. So let's start by importing the data set and let Python know what all crux we need from the data set. Firstly, you need to create a variable. So I'll be creating a variable named dataset. Then we'll be using a class by the pandas function, which is pd.readcsv. And it takes only one attribute, which is the name of the file. So that is data.csv. Next, we are going to be creating something called dependent and independent variables. So as you can see, the purchase class is dependent on all these three columns, right? So we name the purchase class as the dependent variable and all three as independent variables. So whether the person is from France or Spain or Germany, that is independent, right? That is not dependent on any pre-existing variable. So I hope you understood what these things are, because they're going to be used a lot in machine learning. So we are going to be creating another variable called x, and that will have all the values of these three columns. All right. So again, we are going to call dataset, the variable that we created. Then we are going to be using a function named ilog. All right. So this takes two parameters. First, we are going to specify the rows that we need. So we need all the rows. So just empty the range and it will select all the rows. Then we are going to be needing a range from the first to the third column, right? So if you are familiar with Python, you would know that if you just create a colon and enter the last column, it will give you the values till the second last column. So in Python, if you don't know, the first value of the range is always included and the last value is never included. So -1 is the last column right here. So I'm creating the data set from nothing to -1, which means from the starting to the second last column. Next, we need to get the values. So just call values after this. We are going to be doing the same thing for the independent variable. So we are going to be calling y, then again data set. And this is not that different, but we just need the last value. So we are going to be selecting all the rows and then -1, which just contains the last row. And again, we are going to be calling dot values for it. All right. So now we are done importing the data set. Then we have got the dependent variable vectors and the independent variable vectors. Now we are going to be just seeing what x looks like. Print x, just run it. And so we did not run these files earlier. So we have to run this libraries file first, then this one. So we had to do read_csv. That was my bad. And last, we can just print x, right? So there we go. We have got x right there. And as you can see on these cells that there is nothing, it just displays NaN, right? So as you can see, we have completed the first step, and let's just print y as well. So print y, run the cell. And as you can see, we have got all the values of the last column. So we have got the dependent variable vectors and the independent variable vectors. Next, let's go on taking care of missing data. So as I have mentioned many times in this video, there is missing data here and here. So let's see how to tackle that. So in this, we are going to be using a library named Sklearn, and which is a library which will be using a lot in machine learning and a lot throughout your career. So we are going to be importing from sklearn.impute. We are going to be importing simple imputer, right? So next we are going to be creating a variable. Let's call it imputer itself. Then call this class, which is simple imputer. So again, I'm telling you, if you don't have a strong grasp on Python, you won't be able to follow through, right? So this simple imputer class takes two arguments, right? So the first one being missing values. So we have to tell where the missing values actually are, right? So yes, missing values, and we are going to be telling the missing values as np.nan. What does that mean? As you saw here, we got an NaN wherever the missing value was, right? So NaN basically means there is a missing value and it is a character of NumPy. So we just call np.nan, right? Which gives us all the missing code cells. Then as I told you, we are going to be using the mean strategy here. So what that means is you can see all these values. So we are going to be taking the mean or the average of all these values and we are going to be putting on the missing blocks. So that is not necessarily always the case in every data set. We also sometimes use the median and many more advanced things. But in this case, as you can see, there is a lot of randomness. The last value is 27, then the first one is 50. And that just comes with practice on what machine learning model you have to use what. And mostly, in most of the cases, it's mean, right? So we are going to be telling strategy, which is in quotes mean, right? Then we are going to be using the fit and the transform method. So let me tell you what that is. So on the imputer variable that we just made, we have to import a fit class, which takes in, again, you guessed it, the X parameter. Then here we are going to be telling all the columns, and let me just explain what is happening right here. So we are calling a class of the fit class from the sklearn impute library. So what fit basically does is that it finds out everything that is there in X dependent variable vector and all the rows and 1 and 3. So as I told you earlier, it will include the first row but not the third one. So you get these two rows in between. So that is where all the values you want to put are, right? So next we are going to be using imputer. Then we are going to be using the transform function. Here, as you can see, we will again be using X, and again the same thing, we will be taking all the rows and just these columns, and we want to store X, whatever this is. We want to store whatever this is output, whatever the output of this function is, into these code cells, right? So here we just got everything and we knew what to put, and in these two we are putting everything where it is required, right? So let me just copy this and I'm going to paste it right here, make a variable and equate it, right? So now taking care of missing data is all done. Let's just go and print out X, right? So run this code cell, successful, run X. As you can see, we have got the mean values right here. So voila, we have got the missing data. Next, we are going to be encoding the independent variables and the dependent variables. So basically what encoding means, as I told you earlier, we are going to be taking all of these and making a binary sort of thing out of it, and so that we can judge it by the machine learning model. So the first library we need here is from sklearn again. .compose, you need to, we just need to add from sklearn compose. We need to import a library called column transformer. All right. So we also will be needing another library here. So let's take that for later. Here again, we create another variable CT and we call the column transformer class. Column transformer, right? So right here, we'll be needing another library. So again, from sklearn preprocessing, we are going to be importing the one hot encoder class, right? And in the column transformer function, we need to give it 3 variables. So we are going to be specifying again a variable. So we are going to get transformers, and here we are going to be creating a list. So here basically we'll be specifying on what encoding we want to do in this, and we are not going to be doing the 1, 2, 3 encoding so that there is a pattern in the machine learning model. We are going to be getting extreme random results. So like France will be encoded as 001, then Spain as 110, something like that. All right. So the first thing that you're going to call is so first you're going to put a bunch of parentheses, and here we are going to call encoder, right? So we want to encode the data, and by separating comma, we are going to be telling it how we want to put it. So we want the one hot encoder right here with the one we imported, and put a bunch of parentheses. Then comma, we are going to specifying 0. So what does this 0 mean? So we are coding the independent variable. So that means this, and 0 just means to select this column right here, right? So the only independent variable vector that we need to transform is the first column. So we need to encode it using the one hot encoder and the first column. So there is another argument that this actually takes, that is the remainder argument. So all you need to do is that you have to add a comma, and then you have to add a remainder. So I'm going to explain what that actually means, and thus in string just select pass through, right? So basically what this means is that any data that is missing out there, just go through it, just pass through it, don't just look at it, right? So basically this should be enough, but we need all of this data into an array. So all you need to do to get anything in an array is, like, I'm going to be getting it to x equals np dot array ct dot fit transform, and just select x here. All right. And we are ready to run this. So let's just give it a whirl. As you can see, done successfully. Then let's just print out x, right? And voila. As you can see, the France, Spain, Germany got encoded into some gibberish right here. So that is basically binary. Then we are going to be encoding the dependent variable vector, which is the last column. So this, as you can see, is just yes, no, right? So we won't be using the one hot encoder here. We'll be using the label encoder. So we need 1 for yes and 0 for no. All right. So again, from Sklearn dot preprocessing, we are going to import label encoder. Then this is actually quite simple. We just need to equate label encoder to this class. Next, we are just going to be using the fit transform method to fit y. So let's just say y equals le dot fit transform, and then we are going to put y right here. All right, so that's about done for this column, and this was a bit simpler because we just need 1010 here. So let's just print y. Go, and as you can see, we got these values. Next, we're going to be splitting the data set into the training set and the test set. All right. So we're going to start by importing a few libraries. So Sklearn has another library for it. So we are going to be using from Sklearn dot model selection and import train test split. All right. So we are going to be, as you know, we are going to be splitting the data into training and the test split. If you don't know what this is, just go back earlier in the video and see that where I explain what this actually is in the PowerPoint presentation. So next we are going to be creating 4 variables. First is x train, x train, comma, x test. Same for y train, comma, y test. All right. And here we are going to be using the train test split method. So train test split, and let's see what all this demands, right? So first we need to give it x, which is our dependent variables vectors, y, then we are going to be specifying the test size, right? So let's say we just need 20% of the data for test and 80% for training, right? That is a better choice. So we are going to be using test split equals 0.2, right? So 0.2 is actually 20%. Whoops, this should be test size, my bad. So as you can see right here, we are going to be again specifying a variable which is random state. All right. So this is basically, this will come in future machine learning models, but just for now, just understand that this is a variable which comes in the train test split, and we are going to start setting it to 1, right? And now we are ready. Let's just try to print xtrain and xtest, print xtrain, right? And let's just run this. Whoops, we did not run this first, then run this one, then print xtrain, right? So as you can see, we have the training set right here. So it has separated these two values. Then let's just print everything. All right. So xtest, right? The same thing. Then again, we are going doing it for y. So let's do y test. And lastly, let's do it on y train, right? Okay. Y train. Yes. Okay. So now we are going to doing feature scaling. Now, most frequently asked question in machine learning community is, should we do feature scaling first or splitting the data first? So the answer is actually really simple, right? So feature scaling is basically that we take all of these and put it in a same value bar. So we are going to be encoding it in -3 and +3 values only. So all of these will be encoded in -3 and +3. So the machine learning model will know which is more and which is less. So as you know, we have encoded all our data now. Now it is in crude form and we have to get it in the same values, right? So the same thing you do in maths or physics for units, all right? So we need to get all the units straightened before we can perform any calculations on it. So again, yes, you guessed it, we are going to be using Sklearn. Now we are going to be using pre-processing again. Then we are going to be importing the standard scalar function. So we are going to be using SC, right, and standard scalar. Here, let's just go right here and press enter. Now we are going to be doing it for the dependent variable vectors. So let's just go on xtrain and we are going to be specifying a range right here. Range is all columns and everything till 3. All right. So we are going to be using this for the training and equals. Again, we'll be using the fit transform method. All right, the fit transform, and here we'll be putting this as the argument, and we'll be doing the same thing for xtest and specifying the same range actually. All right, we are again going to call the SC fit transform method, and we are just going to change this to xtest, and voila, we have done feature scaling. Let's just try to run it, and no errors. Print xtrain, let's see, and boom, we have got all the values in between -3 and +3. All right, same, let's do it for printing xtest, and there we go. So this was the end of the feature scaling. I hope you learned something, and if you want more machine learning tutorials like this about regression, linear regression, multiple regression, and so on, just leave it down in the comments below, and I'll see you guys next time. So if you like this video, be sure you smash that like button down there, subscribe to the channel, and if you want more such machine learning and cybersecurity tips, just comment down below. Until then, keep hacking.